Hi all, good morning to everyone. We have discussed recursion in the last class. Can you recall what is a recursion?
A function calling itself, sir.
Yeah, a function calls itself. That is said to be a recursion. In recursion, there are two important things that we have considered. One is, please recall that. One is the termination condition. When to terminate a recursion, we need to specify a proper termination condition. How many termination condition can be defined? We can define one or more termination conditions. Second one, carefully define the recurrence relation. The recurrence relation is to be the recursive relationship. When we define the recurrence relation or a recursive relation, we need to use the same function name and we need to modify the new actual parameters in the function call. Suppose f, this is initial formal parameter list. Based on these formal parameters, here we need to modify the new or initiate a new recursive call. So how long we are going to initiate the new recursive calls? Until some termination condition is satisfied. So here we can check the termination condition. Here also we have discussed that the formal parameter is playing a major role. So with the help of a formal parameter, we can terminate a recursion. Here also by modifying the values in the formal parameter, we can initiate a new recursive call. So that a function f is being called within the same function itself. How long this has been carried out means until the termination condition is satisfied. When the termination condition is satisfied, a control may come out of the function definition. That means the control terminates the recursion so that it has to go to the calling phase. That is the logic of recursion. We have seen how to print the numbers from n to 1 in the reverse order. For example, f of n. Here we have printed the value of n. Then we have decremented the value of n by 1, f of n minus 1. Before printing, here we have checked the value of n is less than 0 or less than 1. If n is less than 1, we need to return terminate a recursion. Else, we have printed the values of n and we have initiated a new recursive call f of n minus 1. This is a problem that we have discussed in the last session. Have any doubts in this problem? If you have any doubts in this recursion, you can ask. Otherwise, we will move on to solving new problems. Have any doubts in this program, recursive program, printing the numbers n to 1 in the reverse order? Okay, we move on to the next example using recursion. Please take this example. Find the sum s is equal to 1 plus 2 plus 3 plus etc. n using recursion. This is of course the sum of first and natural numbers. One can easily verify that the result is equivalent to 2. N into n plus 1 by 2, where n is the positive integer. We can design a for loop using, we can design a for loop, right? So that we can evaluate the value of s, or we can use a while loop, do while loop to evaluate the value of s. Here the problem is apply the recursion to find the evaluation on the right hand side of s. So to find 1 plus 2 plus 3 plus etc. n, what we have to do, we need to apply a recursion. Just listen here, let us try to design a recursive logic here. For example, the function name is sum of n numbers, or I write simply the function name is f sum. Assuming that f sum, this is the name of the function finds the evaluation of 1 plus 2 plus 3 plus etc. n. That is the purpose of the function is to find the value of s. Clearly, when we call a function f sum, we are expecting the final value of s that needs to be returned to the calling place. So first think of the actual parameter. Suppose if this is the main function, formally, right, I write that statement f sum. What is the input parameter required? F sum semicolon. What is the input parameter required? What is the input value required to evaluate this expression?
Sir, any variable int j.
Yeah, any variable into j, or you can up to right find the value of n, 1 plus 2 plus 3 plus up to n. That means the first n terms are required. First n terms are required. That means the input to the evaluation is the value of n. N represents the integer. We need to evaluate the value of s up to that place, 1 plus 2 plus 3 plus etc. n. So here, assuming that one input is required, input is n, and clearly the value n is
Sir,
passed as the what on?
sir, your voice is
Who
not
is
clear, sir.
this?
It's breaking.
What about others? Is this audible? In the input is required one integer variable n. We are passing
Hello,
that
sir. Are you
integer value.
speaking? I'm not audible, sir. You're not audible,
What
sir.
about
Hello, sir.
others? Others is this audible? Harini, Amritashri, is this audible?
Hello, sir. Sir, try to refresh, sir. Maybe then we'll be able to hear. We can't hear
Sai,
you, sir.
Bhargav,
Sir, breaking, sir, little.
Swed, yeah, 1 minute. Sweda, Manasa, is this audible? Harini, Amritashri,
Yes, sir.
Vasudha Jit, I think.
Sir.
Vasudha Jit, please check your network connection. I think problem is at your side. Please check it. I am speaking louder. Please check it. Okay, here, what is the input required? Input is one n. N is the integer variable. The integer n is passed as a parameter to the function called f sum. What is the name given to the parameter n? Anyone? What is the name given to the value, right, or variable n here? What is the parameter name n? What can we call it? F sum of n is a function call statement, right? What is the name given to the parameter n? Manasa,
Terms.
what is the name given to the variable n? N is said to
Actual
be,
parameter.
yeah, you need to recall it carefully. Actual parameter. Actual parameters are specified in the function call. Please remember the entire rules of function. This is the function call statement. F sum of n. This initiates a function f sum with actual parameter n. What is n? N is the integer input. This is passed as a value to the function f sum of n. Suppose here I write a function f sum of n. F sum of n. Suppose into n. The same n is being assigned in the parameter n. What is the name given to this n? This is the function definition.
Formal parameters, sir.
Yes, very good. This is a formal parameter. We have seen that actual and the formal parameter may be the same name, but this n is local to this main function. This n is local to this user-defined function. So assuming that the return type is integer 1, we can add it, no problem. Int f sum, and we can make the function prototype here. We will add it in the program. Prototype should be added here. First, let us devise the logic and verify its correctness. Then we can go for its implementation. So f sum of n, this indicates that up to n we need to find the evaluation. In the function definition, int return type, f sum is the function name, int n is a formal parameter. So here I write in the command evaluate s is equal to 1 plus 2 plus 3 plus up to n. So up to n we need to find the sum. Can you tell me what type of statements are needed here to make recursive call as well as the termination conditions? How can we design the logic? Have any idea? Already we have solved the example, printing the numbers from n to 1. The same way, can you design the logic to evaluate the right hand side of this equation? S is equal to 1 plus 2 plus 3 plus etc. n. Any idea how to design a recursive call here and what will be the termination condition? Okay,
So it can be called by giving n plus 1. Like calling
n
it
plus
again.
1. Okay, okay, let us design the logic, right? If it is incorrect, we need to modify it. That is a way of designing the algorithm. F sum of n. Here, n is for example 10. We need to find, right, 1 plus 2 plus 3 plus etc. final value is 10. We can design the logic in several ways as we discussed earlier. So one possible logic, if you write f sum of next value n minus 1, what happens? F sum of 9 is called. When you call f sum of 10 first time, we can add a value n into the variable s. So if we write n plus, this is plus n plus f sum of n minus 1, what happens? N is 10, 10 is considered, plus f sum of n minus 1, n minus 1 is 9. Next stage, f sum of 9 is called. 9 will be the new actual parameter. So when calling f sum of 9, already we have the result, right? N plus f sum of n minus 1. So if we write 10 plus one more time, right? The current value of n, this is 9. 9 plus, if we write f sum of n minus 1, this becomes 8, f sum of 8. Then 10 plus 9 plus new recursive call, it invokes f sum of 7. So this way, finally we can reach 10 plus 9 plus 8 plus etc. 3 plus 2 plus 1 plus f sum of n minus 1, that is 0. So when f of 0 is called, when n becomes 0, to the calling place, what we can do, we can return a value 0. So when n is equal to 0, we can return a value 0, so that we can terminate the process, terminate the recursive calls. So I write the logic here. The termination condition is checked first. If n is equal to 0, then the value to be returned is 0. Return 0. Else, I do like to return this entire evaluation. Else, return n plus f sum of n minus 1. Of course, in this example, we have not used a local variable, for example, s, to evaluate the recursion. Instead, in the return statement itself, the recursive call is invoked. So return n plus f sum of n minus 1. For example, to understand that recursive call, let us take a small value of n. Say n is equal to 5. What is the initial call? Initial call is f sum of 5. That means the local variable n receives a value 5. Formal parameter here, n receives the value 5. Checking if n is equal to 0, return 0. Currently, the local parameter or formal parameter n is equal to 5. This is not equal to 0. So the expression to be evaluated or statement to be evaluated is control goes to execute the else part. Please understand this expression. Return n plus f sum of n minus 1. I write first return n plus f sum of n minus 1. That means I write in the next line return n is 5 plus f sum of n minus 1. 5 minus 1 is 4. This is not the simple expression. Can ask what is a simple expression? The expression that involves variables without any recursive call are said to be simple expression. What is the syntax of a return statement? Return statement syntax is return expression. The expression is evaluated and the value is returned to the calling place. Return expression. Assuming that this is a simple variables or simple expression that is evaluated and the value is returned to the calling place. This is the first time we are introducing the function call in the return statement. Carefully understand. Return n plus f sum of n minus 1. This is not a simple function call. Instead, this is a recursive call with the return statement. So return n plus f sum of n minus 1 means return 5 plus f sum of 4. In this case, the expression is not yet evaluated. Please understand. 5 plus f sum of 4. Since f sum of 4 is the new recursive call, we have not yet obtained the value of f sum of 4, so that something f sum of 4 plus 5 is not returned in stride. That means f sum of 4, since this is another recursive call, even this may be placed inside the return statement. Now control goes to find what is the value of f sum of 4. So when you call f sum of 4, what happens? The new recursive call is made in the function f sum of int n, so that the value of n receives 4. So when n receives 4, please check the statements. If n is equal to 0, return 0. Now n is equal to 4, this is not equal to 0. So what happens? The expression to be evaluated is return n plus f sum of n minus 1. So this returns, I write here, return 4 plus f sum of what is current n? Current n is 4. 4 minus 1, 3. 4 plus f sum of 3. This is the expression to be or statement to be executed when calling f sum of 4. Actually, f sum of 4, f sum of 5, this is the initial call. I put 0. F sum of 4, this is the first recursive call. Then to find f sum of 4, this is not a simple expression. Instead, it invokes the second recursion as f sum of 3. So to evaluate f sum of 3, what we have to do? We need to pass the actual parameter n as 3. So that in the function definition, the formal parameter n also receives the same value n is equal to 3. It checks if n is equal to 0. This n, 3 is not equal to 0. So it returns a value n plus f sum of n minus 1. This expression clearly return 3 plus f sum of n minus 1. 3 minus 1 is 2. So f sum of 3 evaluation is not a simple expression. Again, it involves the recursive call, because 3 plus f sum of 2, f sum of 2, this results in the third recursive call. I put 3 here. Next, f sum of 2 means the value, formal parameter, n is passed, n receives 2 in the function definition. N is not equal to 0, so it executes this statement. Which one? Return n plus f sum of n minus 1. So I evaluate here, return n plus n is 2, or 2 plus f sum of n minus 1. 2 minus 1 is 1. So it seems that the value of f sum of 2 is not even a simple expression, since here f sum of 1 is introduced. 1 means this invokes another recursion. This is the fourth recursion. So when calling f sum of 1, the actual parameter is 1. Formal parameter receives n as 1. 1 is not equal to 0. So it evaluates the return statement, return n plus f sum of n minus 1. In this case, the statement to be evaluated is return n plus n is 1, 1 plus f sum of n minus 1. N minus 1 is 1 minus 1 is 0. So it seems f sum of 1 is not even a simple value, or even we can return a value 1. Then the actual parameter n becomes 1. That is also a correct one. We can reduce the operations. Anyhow, right within this logic, let us trace first. F sum of 0, this invokes the next recursion. Recursion number is previously 1, 2, 3, 4, 5. Fifth time, the recursive call has been made. In this stage, of course, this is the last recursion. The actual parameter is passed as 0. That means 0 is the actual parameter. This 0 is assigned to the formal parameter n here. So clearly this is the formal parameter n is equal to 0. Checking if n is equal to 0 in the function definition, what are we returning? We are returning a value 0 to terminate the recursion. So clearly here n becomes 0. We need to return a value 0. I write the statement return 0. Return 0. In this case, who is the caller? Right? The caller is, who is the caller? F sum of 0. Right? This is the caller. So what happens in the backward computation? I write this flow. Please understand. This is with respect to the backward procedure. For example, return 0, 1. I put 1 here to indicate that this value is returned to its caller. Who is the caller? F sum of 0 is the caller. F sum of 0 just replaces its returned value as 0. So I write this evaluation as 1 plus 0. 1 plus 0 is equal to 1. Now please consider this return statement. This return is executed first in the reverse order. Then this 0 is replaced to f sum of 0. 1 plus 0 is equal to 1. Now have a look into this return statement. Return f sum of 0 is evaluated as 0. Recursion is terminated. 1 plus 0 is 1. Now return 1, what happens? Return 1 returns a value to its caller. Currently, who is the caller? That means return to, this is the second return statement in the reverse order. The corresponding caller is f sum of 1. So what is the value of f sum of 1? This return 1 plus 0 is equal to 1. The integer 1 is returned to this calling place. So I write here this value. This 1 is returned to this place. F sum of 1 gets a value 1. Now return this expression. Have a look into this, the return statement. Return 2 plus f sum of 1. F sum of 1 receives a value 1. So it seems 2 plus 1. 2 plus 1 is equal to 3. Right? This is the third return statement executed in reverse order. So this return, right, the value to be returned is 3. Who is the caller of the function? F sum of 2 is the caller. So this 3 is returned to this place. So this place receives a value 3. Return 3 plus 3 is equal to 6. Now we are evaluating this return statement, right, a fourth time in the reverse order. Return 6. What is 6? 6 is returned to its caller. So f sum of 3 here receives a value 6. 4 plus 6 is equal to 10. Now return this 10. Who is the caller, right? This return statement. Fifth time. the corresponding caller is this value. For example, this 3 is returned here, then this 6 is returned to this place, 4 plus 6 is 10. Then 10 is returned to its caller. Its caller is f sum of 4. Now only f sum of 4 receives a value, this return value, right? 10, 5 plus 10. Still here we have a return statement. Return 5 plus 10. 5 plus 10. This is evaluated. 15. This is a final result. So far we have 5 return executions. This is the first return statement. This is the second return statement. This is the third return statement. This is the fourth return statement. And this is the fifth return statement. And this is the sixth return statement. The sixth return statement returns a value 15 to its caller, assuming that the caller is a main function. So main function here receives a value f sum of 5, right? So the caller is here f sum of 5. This receives a value of 50. This is the trace, right? To understand the recursion, how the recursive calls are made, and how the termination condition is properly executed to terminate the recursion. Hope you understand this trace. Have any doubts in this? Shall we check its implementation? Have any doubts in this recursive call? Please tell me. Shall we check its implementation? Okay, please take this program. 5 new. Find the sum of first n natural numbers using recursion. This is the problem. So evaluate, say s is equal to 1 plus 2 plus 3 plus etc. plus up to n. Include the header file, hash include stdio.h. Define a main function into main. Please consider this is the algorithm, right, that we have checked, verified its correctness. This needs to be converted into a program. Clearly we need one integer value n. So declare one integer variable n here, int n, printf slash n, enter the value of n. Then get its value using a scanf statement, scanf percentage d ampersand n. Now what happens? The value of n is received in the variable n. We need to find right the evaluation, say f sum of 5. So let us evaluate right using the printf statement, printf percentage d. We can call a function f sum with actual parameter n, and the returned result is being processed in the printf statement. Finally have the expression return to 0. Now we need to define the function f sum, which takes one integer parameter and it returns a result, integer result to the calling place. Whoever is the caller, right? It may be a main function or it may be the same function. So write the return type as int. Function name is say f sum. Formal parameters will be defined. Let us have the variable n, int n. This is the actual function definition. Within this, we need to define the proper recurrence relation, recursive condition, recursive relationship, and the termination conditions. Recursion will be called right repeatedly until the termination conditions are met. So, what is our termination condition? We have checked if the value of n is equal to 0, then the value to be returned is 0. Or you can control through if n is equal to 1, return 1. That means when n becomes 1 here when n becomes 1, simply you are returning a value 1 so that no more recursion will be taken place. So whichever is right, no problem. Here I write if n is equal to 0, the value to be returned is return 0. Else, if the condition fails, if n is equal to 0, return 0. Else, we do want to return a value, return n plus f sum of n minus 1. Take if we have carefully devised the termination condition and recurrence relation based on the formal parameter n. Here actually the n in the statement is the actual parameter. In the function definition, int n, this n is the formal parameter. As we discussed earlier, if n is equal to 0, return 0, this is a termination condition. These two statements, right? Termination condition. Termination condition. Okay. Else return f sum of n minus 1. This is a recursive relationship. So recursive relationship or recursive call, and the termination conditions are condition specified based on the formal parameter n. When n is 0, right? The conditional statement that we have written is if n is equal to 0. This formal n is introduced in this conditional statement. Then this n is being modified in the new actual parameter of function called f sum as n minus 1. So this n is being applied both in termination condition as well as recursive relationship, so that we have the correctness of the program s is equal to 1 plus 2 plus 3 plus etc. n. Then we need to define the function prototype. What is the function prototype? Return type int. Function name is f sum. Its type is integer 1. So you must specify the formal parameters type. Here we have only one formal parameter. Its type is of integer 1. So int is mentioned here. Int f sum of int semicolon. This acts as a function prototype. Function prototype. So we have designed a main function. Input values are obtained. Input n is passed to the printf statement. F sum of n. Function is defined. Actual parameter, formal parameter. Matching is okay. Termination condition, recursive relationship are correctly tested. Now let us run the program to verify the result. Save CP47 F9 No compile time errors are reported here. Program has been compiled successfully. Control F9. Enter the value of n. Say I give a value n. So the result, the value to be returned is f sum of 5, right? Returns the final value as 15. Suppose n is equal to 10. Can expect a value 55. Have any doubts in this example? Understand the logic of recursion. How do we solve the problem using a recursion? Have any doubts? Harini, Shweta, Vigneshwaran, Manasa, have any doubts?
No doubt, sir.
So hope you are clear, right, with this example. Now I ask you a question. This is one logic. This is one logic to solve the evaluation. S is equal to 1 plus 2 plus 3 plus etc. n. Is there any other logic to replace these? That means I ask, is there any other logic or are there any other logics, right, to replace these termination as well as recursive relationships?
We can use for loops.
If you use a for loop, it should be based on recursive relationship. So I mean, in the same recursion, is there any other logic?
Why, sir?
While see whatever is, it should be the part of a recursion. So I think here there is no need to use for statement or while statement, iterative statements. Since the function is being called itself, we are repeatedly calling the function. At the same time, the current n is being added in the return statement. So this is one logic. Any other logic by modifying the termination as well as recursive relationship. You can also design a logic in the forward computation. For example, here you can use one variable, say j. You can initially start with the j as 1 and you can increment the value of j by 1. Suppose initial call is f sum of 1. So this is 1. Int this is 1. We can pass right two parameters, say 1 comma n. So in that case, this variable, right, j is being added here. Return j plus f sum of j plus 1. That means finally you need to check if j reaches a value n, then you can return a value n. So that stage you can have the forward computation 1 plus 2 plus 3 plus etc. n. So whichever is, both cases result in the same output. S is equal to 1 plus 2 plus 3 plus etc. n. Hope you understand. This is one example. Now let us solve the next problem. Let us consider the factorial problem. factorial of the integer n. So consider the problem n factorial. Already we have designed a logic using iteration for loop. As we have n factorial is equal to 1 into 2 into 3 into etc. n. This is evaluated using the for loop, while loop or do while loop. So simply write using iteration. When we try to convert this iteration into a recursion, just to think of how we have solved 1 plus 2 plus 3 plus etc. n. Addition is replaced using the multiplication operation. 1 plus 2 plus 3 plus etc. plus n is replaced as 1 into 2 into 3 into etc. n. So we need to think of a proper logic to convert this additive problem into the multiplicative problem so that the value of n factorial is computed and the result may be returned to the calling place. Suppose we have a function fact. Assuming fact is a function and we are passing the initial value of n so that the value of n factorial is computed. Have this inside the main function. For example, from the main function, we do want to initiate a call fact of n. Assuming here the fact function is defined fact with one formal parameter, since the actual parameter is of integer type. This would be defined in the formal parameter. Formal parameter, for example, int n. This n is being received in the formal parameter n here. Now here we need to devise the logic to find n factorial, that is 1 into 2 into 3 into etc. n. As we designed the logic for addition, if n is equal to 0, we have returned the value 0, else we have returned n the set sum of n minus 1. Now we can check if n is 1. If n is 1, let us process in the reverse direction. N into n minus 1 into n minus 2 into etc. 3, 2, 1. The final value of n becomes 1. Clearly, we need to return a value 1. So, if n is equal to 1, return the integer 1. Else, return, as we discussed earlier, where n plus f sum of n minus 1. So here the equivalent function is n into, addition is replaced with multiplication, n into fact of n minus 1. N into fact of n minus 1. This is the recursive call statement in which fact of n minus 1 becomes the new recursive call so that the actual parameter is updated to n minus 1. So initially fact of 5, then fact of 4, fact of 3, fact of 2, fact of 1, then fact of 1 means we are returning a value. If n is equal to 1, return 1 so that fact of 1 is computed. From fact of 1, we need to find the fact of 2. From fact of 2, we need to find fact of 3. From fact of 3, find fact of 4. From fact of 4, evaluate fact of 5 and return the result to the calling place. This is the simplest logic to convert the iteration into a recursion one. Let us check its traces before its implementation. Suppose the actual parameter is 5. Find the value of fact of 5. This is the actual parameter. So clearly the function to be called is fact of 5. So n receives a value 5 here. N is equal to 5 is being received. In the function definition, we are checking if n is equal to 1. If n is 1, return 1. Now, the value of n is equal to 5. This is not equal to 1. So, it returns 5 into fact of 5 minus 1. 5 minus 1, right? This statement is executed. N into fact of n minus 1. Return 5 into fact of 4. Now what happens? Fact of 4, this is the first recursive call. Fact of 4 is evaluated as the formal parameter that n is equal to 4. 4 is not equal to 0. Return n into fact of n minus 1. So 4 into fact of n minus 1. N minus 1 is 3. 4 into fact of 3. Then next stage, 4 into fact of 3. This is the value to be returned for fact of 4. To evaluate fact of 4, the formal parameter is n is equal to 3. 3 not equal to, right? What one? 1 here. Here also. This is not 0. N is equal to 4, not equal to 1. So n is equal to 3, this is not equal to 1. In this case, we need to check the value of n, right? N is not equal to 1. So what happens? We need to return the expression, return 3 into fact of 3 minus 1. 3 minus 1 is 2. Fact of 2 is evaluated next, in which n is equal to 2, 2 not equal to 1. So fact of 2 evaluation is return 2 into fact of 2 minus 1. Fact of 2 minus 1 is 1. 2 into fact of 1, in which fact of 1, this becomes the next recursive call in which n is equal to 1. So in the final recursive call, we have checked if n is equal to 1. If n is equal to 1, the value to be returned is 1. So here fact of 1, the value is 1. Return fact of 1. Fact of 1 first returns a value 1. So return 2 into 1. 2 into 1 is equal to substitute a value of the fact of 2. Now fact of 2 becomes 3 into 2. This is 2. 3 into 2. This is equal to 6. Return 6. The corresponding caller is fact of 3. Fact of 3 receives a value 6. 4 into 6. 4 into 6. This is equal to 24. Return 24. The corresponding caller is here fact of 4. Fact of 4 receives a value 24. 5 into 24. This is 120. 120. Return 120. This is returned to its caller. Caller is fact of 5. So clearly we have n is equal to 5. 5 factorial is 120. This is being returned from the function definition, recursive function. So the final value of a return statement is, right, 120. We have clearly specified the termination condition and the recursive relationship. Have any doubt in this recursive logic? Factorial computation, any doubt in this?
No, sir.
Okay, now let us check its correctness of the program, right? So correctness of the algorithm, right? Let us check its program. Next one, find n factorial using recursion and sketch its trace or n is equal to 5. So write a main function hash include stdio.h into main, declare one variable n, int n, printf statement, a printf, please enter the value of n, write a scanf statement, scanf percentage d ampersand n, then in a printf statement, printf percentage d factorial is percentage d, comma, first percentage d say n, 5 factorial is n, comma, second percentage d, let us define a function fact with one integer parameter, return 0. Main function has been returned. Then write the user defined function as a recursive logic to find the value of n factorial. So let us write a logic int fact. Formal parameter is, for example, int n. This algorithmic structure should be converted into the program, right? So already we have returned the termination condition. If n is equal to 1, return 1. Else return n into fact of n minus 1. So write the same. If n is equal to 1, the value to be returned is 1. Return 1. Else return a value n into fact of n minus 1. Then complete the main function section, the function prototype. Function prototype is int function name fact. The parameter list is of type integer 1. This is function prototype. Fact of n, this acts as the function call in which what is n? N is the actual parameter. N is the actual parameter. In the function definition, what is n? N is the formal parameter. To do the trace, here n is equal to 5. Function to be called is fact of 5. We are checking the values. If n is equal to 1, n is equal to 1, a question mark. If n is equal to 1, we need to return a value 1. Else return n into fact of n minus 1. Initial value of n is 5. 5 not equal to 1. Condition is false. If the condition is false, the statement to be executed is return 5 into fact of n minus 1. N minus 1 is 4. 5 into fact of 4. This is for a fact of 5. Next, In this case, what happens? Return 5 into factor for evaluation. Current n is 4. 4 is not equal to 1. So this evaluates us 4 into factor of 3. 4 into factor of 3. Then next stage, here if you want we can write current n is equal to 4. 4 not equal to 1. False. So evaluation is return 5 into 4 into factor of 3. Then n, the value of n is 3. Condition n is equal to 1 is false. So I write in a single return statement as 5 into 4 into factor of 3 evaluation is 3 into factor of 2. Then new actual parameter is 2. Condition n is equal to 1 is false. So return 5 into 4 into 3 into 2 into then factor of 1. N is equal to 1. Condition is true. The value to be returned is 1. So return 5 into 4 into 3 into 2 into factor of 1 is 1. So the entire evaluation is 120. This is returned to the coding phase so that the actual parameter n 5, right? N is equal to 5. The equivalent value 5 factorial is 120. This is processed in the equivalent are in the printf state. So return n into factor of n minus 1 finally returns the value of n factorial and is being processed in the printf statement. If you like, you can declare one integer variable here into, for example, result. Result is equal to factor of n. Then you can print the value of factor of n. Because here the termination condition is this one. If n is equal to 1, return 1. Else we need to return a value n into factor of n minus 1. This evaluates 1 into 2 into 3 into etc. n. N factorial is 1 when n is equal to 1. Else n into factor of n minus 1. Otherwise, this is the recurrence relation. We can write this as factor of n. Factor of n is equal to 1 when n is equal to 1. Otherwise, this is equal to n into factor of n minus 1. So if you call this is equation 1 and this is equation 2, to prove factor of n is equal to n factorial, let us start from the left hand side factor of n, assuming n is not equal to 1, write n into factor of n minus 1 for n is not equal to 1. Assuming n is one integer not equal to 1, so factor of 1 is taken from this equation 2. From 2 n factorial is n into factor of n minus 1. What is a recursion? The function is being called itself by changing its actual parameter. So I write n into, carefully look into the value of factor of n minus 1. Factor of n is n into factor of n minus 1. So to find factor of n minus 1, I write separately factor of n minus 1 is obtained by putting this n is equal to n minus 1. So put fact of n minus 1 is obtained by putting n is equal to n minus 1 in equation 2. So n into fact of n minus 1 on the right hand side is n minus 1 into fact of n minus 1 minus 1, that is n minus 2. So we have obtained the value of fact of n minus 1 as n minus 1 into fact of n minus 2. So I write here n minus 1 into fact of n minus 2, since fact of n minus 1 is evaluated here and the value is substituted here. This one. This is the value of fact of n minus 1. Hope you understand. If we extend the recursion one more step, this is equal to n into n minus 1 into, have a look into fact of n minus 2. To evaluate fact of n minus 2, put n is equal to n minus 2 in equation 2. In equation 2, fact of n minus 2 here, second equation, fact of n minus 2. Fact of n minus 2 is equal to n minus 2, because on the right hand side n into fact of n minus 1 is there, n is replaced the value n minus 2. So both in left hand side and right hand side we are replacing n by n minus 2. So this n is replaced n minus 2. This n is replaced n minus 2. So n minus 2 into fact of n minus 2 minus 1, that is n minus 3. This value is being substituted here, n minus 2 into fact of n minus 3. I write here, this is equal to n minus 2 into fact of n minus 3, since the value is obtained here. Extending the recursion right one more stage, it seems n into n minus 1 into n minus 2 into, similarly fact of n minus 3 is obtained as n minus 3 into fact of the next one, n minus 4. If we continue this process, in the final stage we have left hand side is fact of n, right hand side is n into n minus 1 into n minus 2, n minus 2 into etc. Finally, have a look into here, n minus 3 into fact of n minus 4, then n minus 4 into fact of n minus 5. This goes on. In one stage we have right 3 into 2 into fact of 1. In this stage, n into n minus 1, n minus 2, etc. 3 into 2 into fact of 1 is a recursive call. To find fact of 1, we need to consider equation 1, because this is the termination condition. Equation 2 is the recursive relation, recursive call. When n becomes 1, the value to be returned is, or fact of 1 is, fact of n is, right, both are same 1. So fact of 1 is 1, since from equation 1, when n is equal to 1, that is fact of 1 is 1. Substituting this value here, then we have the evaluation n into n minus 1, n minus 2, n minus 3, etc. 3 into 2 into 1 are starting from right to left direction. We can write 1 into 2 into 3 into etc. n. This is actually fact of n, that is n factorial. So the recurrence relation is solved. These two equations, right? These are said to be the recurrence relation. Solving this recurrence relation, fact of n is equal to 1 when n is equal to 1, n into fact of n minus 1, otherwise that means when n is greater than 1, we are getting the exact value of n factorial as 1 into 3 into 1 into 2 into 3 into etc. n. So this algorithm is implemented as a program here. If we do the trace for n is equal to 5, we will get a value 120. Let us check the program file, save, CP48, F9. The code has been compiled successfully. Control F9. Please enter the value of n. Suppose I input 5 factorial is 120. Control F9. 7 factorial is 5040. Have any doubts in this example and solving the recurrence relation and the construction of the recursive logic, trace, factorial trace, program, the equivalent implementation?
Sir,
Yes.
sir, once if the condition in if part is true, it will not enter else part, no, sir.
Yeah, once the condition in the if part is true, yes, control will not enter in the false part. Yes.
Then how the fact of one is written here, sir? Like one.
Yeah,
into
good
two.
question. Yeah, I explained here. Have a look into this function definition. One stage when the actual parameter becomes 1, say fact of 1. This initiates the last recursive call in which actual parameter is 1, so that the formal parameter n receives a value 1. When n is equal to 1, return 1. The value is returned to the corresponding caller. So, who is the caller here? Fact of 1 is the caller. Look into this. Fact of 1, this is the caller, where the actual parameter is 1. N is equal to 1. In the function definition, what we have defined, if n is equal to 1, return 1. So here if I write, if n is equal to 1, return 1, always think that return statement returns a value to the calling place when the value is mentioned. We are not assuming a dummy return. Dummy return just returns the control. Here return value is there, return 1. So the caller of fact of 1, this 1 is being returned to this place. That's what fact of 1, this is receiving a value 1, so that we have 2 into 1 is equal to 2. So when n is equal to 1, yes, condition is true, n is equal to 1, control will not enter into the else part. This return statement terminates the value of or terminates a recursive call by returning a value 1. So return 1, right? But logically we mean fact of 1 as 1. So even in the program, when you run the program, if you input a value n as 1, have a look into the screen, control F9, enter the value of n, 1. 1 factorial is 1. How it gets executed, n is 1, 1 is equal to 1 condition is true, that's all, return 1 without executing the recursion, because this is a termination condition. Just returns a value 1 to the calling phase. That's all. So this is how, without executing the recursion, fact of 1 is evaluated. Clear?
Yes, sir. Please.
In case, right, if you input 0 factorial is 1 means, if you expect the program to be perfected, in case if the user enters a value 0, I do like to return a value, right, 1. So here you can write the conditional statement, if n is equal to 1, or, where is or simple, 5. If n is equal to 1 or n is equal to 0, return 1, this is enough. So enter the value of n. N should be greater than or equal to 0 as the integer. Inputting the value n as 0, we can expect 0 factorial is 1. Hope you understand the logic of a recursive logic of factorial n. We have solved the recurrence relation and verified n factorial as 1 into 2 into 3 etc. n. This has been converted into the program and we have verified for the value of n 0, 1, right, and any positive integer n, and we have done the trace. Have any doubt in this, you can ask. Otherwise, we move on to the next problem. So we move on to the next problem. Please take it with respect to the recursive application. Generating a Fibonacci number. Or generating the Fibonacci sequence. Already we have seen the Fibonacci sequence 0, 1, 0 plus 1, right? 1, 1 plus 1, the next number 2, 1 plus 2, the next number 3, then 5, 8, 13, 21, 34, 55, etc. This is the Fibonacci sequence. Already we have designed the logic using iteration. We have checked, right, if A is equal to 0, right, this is one input, B is equal to 0, another input or another initialization, A is equal to 0, B is equal to 1. We have controlled through a for loop, right, so please recall that the algorithm and its trace that we made earlier for a Fibonacci number generation. Using the for loop, right, we have obtained a value of next value C is equal to A plus B, and the values A and B are updated, A is equal to B, B is equal to C. That is iteration. The iteration can be converted into the recursion. So in this case, we can have the function name. For example, let us have in short. For example, I have 3 letters, fib of n. Assuming fib of n is the function name, if you input n is equal to 1, the first integer, for example 0, is output. If we assume when n is equal to 1, fib of n, this is equal to 1 when n is equal to 0. Suppose fib of 0 is 0. If you put n is equal to 1, here we assume the integer 1 is required. Sorry, fib of n is equal to 0 means Or you can consider this way, right? This is not a zeroth number. Okay, we say if n is equal to 1. N is equal to 1 means this is the first integer, assuming the first integer is 0 here. N is equal to 2. The second number in that sequence, right? 1 is required. We need to write the recursive logic so that the nth number in that sequence should be obtained. So this is simply 0 and 1, right? 1 and 1, 2, 1 plus 2, 3, 2 plus 3, 5. So if this is fib of n, and this is fib of n minus 1, n and n minus 1 forms the next number fib of n plus 1. Or simply, if we take, for example, this is fib of n minus 2, this is fib of n minus 2 plus 1, that is n minus 1, n minus 2 plus 1, n minus 1. This is fib of n. So we write the recurrence relation as fib of n minus 1, the previous number, and one more number to its previous, fib of n minus fib of plus fib of n minus 2 when n is greater than or equal to 3. 3 means 3 minus 1 to 2, 3 minus 2, 1. What are these? Why do we need these? N is equal to 1, 0, n is equal to 2, 1. Fib of n is equal to fib of n minus 1 plus fib of n minus 2. Putting n as 3, fib of 3 should be evaluated. Putting n as 3 here, fib of 3 minus 1 is 2, plus putting n as 3 here, 3 minus 2, 1. So fib of 2 and fib of 1, that means the first two numbers in that sequence are required. That's what here we have. When n is equal to 1, the value 0 is returned. When n is equal to 2, the value 1 is returned. So 1 plus 0 is equal to 3. Sorry, 1 plus 0 is equal to 1. 1 plus 0 is 1. So the third number in that sequence, right? This is 1 using this recurrence relation. So to find fib of 3 as 1 plus 0 is equal to 1, this 1 is required and 0 is required. So 1 is being assigned in fib of 2, 0 is being assigned in fib of 1. That's what here, when n is equal to 1, fib of n returns a value 0. When n is equal to 2, fib of n returns a value 1. So that these two conditions are taken as termination conditions. Two termination conditions are required in this problem. Fib of n minus 1 plus fib of n minus 2. Ultimately, this is the first example that you are seeing with two termination conditions and two recursive calls. Fib of n minus 1. This is one recursive call. Say this is recursive call 1. Fib of n minus 2. This is another recursive call. Say recursive call 2. These two recursive calls are repeatedly executed or evaluated until the recursion is terminated in both of these recursive calls. For example, we have assumed that fib of 1 as 0, fib of 2 as 1. Let us evaluate. This is 1, 2, 3, 4, 5, 6, 7. Let us evaluate a value of fib of 7 to bring the value 8. Fib of 7. Evaluate fib of 7. Now what is n? N is equal to 7. In our recursion fib of n, fib of n is fib of n minus 1 plus fib of n minus 2. That's true when n is greater than or equal to 3. So writing that relationship, fib of n is equal to fib of n minus 1 plus fib of n minus 2. This is true when n is greater than or equal to 3. Since n is equal to 7, substituting n as 7, that is fib of 7 is equal to fib of 7 minus 1, this is 6, plus fib of 7 minus 2, this is 4. Clearly, fib of 6 is one recursive call, fib of 4 is another recursive call. Multiple recursive calls are being made in this example. That is possible. To evaluate fib of 6, applying the same recurrence relation, since here n is 6, n greater than or equal to 3, I don't want to write the condition again and again. Since 6, this is greater than or equal to 3, simply I write the right hand side of this fib of n. So that fib of 6 is evaluated as fib of 6 minus 1, 5, plus fib of 6 minus 2, 4. I put the parentheses to conclude this is the value of fib of 6. Plus, to evaluate this fib of 4, I write directly this evaluation. Since 4 is greater than or equal to 3, fib of n minus 1, fib of 4 minus 1, 3, plus fib of 4 minus 2, 2. I put this in parentheses to signify this is the evaluation for a fib of 4. Now it seems 4 recursive calls are there. One recursive call initiates 2 recursive calls. Since currently we have 2 recursive calls, each is occupying or initiating further 2. So 2 into 2 seems 4 recursive calls are met. Let us evaluate one by one. Evaluating fib of 5 next. Since n greater than or equal to 3, this is true. This is evaluated using the right hand side of this equation. Fib of 5, I am evaluating. Fib of 5 minus 1 is 4, plus fib of 5 minus 2, this is 3. I put one parenthesis to signify the value of fib of 5, plus this is added with fib of 4. I put one more opening and closing parenthesis. All are additions, no problem. To conclude, fib of 5 plus fib of 4, plus writing this result as it is, fib of 3 plus fib of 2. Now this is the evaluation for fib of 5. Fib of 4 is required, fib of 3 is required. Then fib of 4 is evaluated next. How we are evaluating fib of 4 here? In the same way, yes. Yes, what is the
Can you
doubt?
explain what's up?
Which one?
This one, sir.
Starting from, okay, when n is equal to 7, this is fib of 7. We need to find the 7th integer in that sequence. Starting from the recursion, Since here, understand the logic, the nth integer is obtained by adding the previous two integers. If this is n, what is its previous integer? This is n minus 1. So fib of n is the nth integer. Identify the previous two integers as fib of n minus 1 and fib of n minus 2. That's what here we put simply. Fib of n minus 1 plus fib of n minus 2. This is true when n is greater than or equal to 3. That's all. This is a simple recursive relationship. This recursive relationship is tested for n is equal to 7. Please understand, here I put n is equal to 7 in this equation. 7 means 7 minus 1 plus 7 minus 2. That is 6 plus fib of 7, right? Okay, what is fib of 7? N is 7. 7 means here 7 minus 1, 6. Then here 7 minus 2. Am I right? What is 7 minus 2? This is 5. Fib of 6 plus fib of 5. Next fib of 6. Yeah, okay. Fib of 6. Fib of 6 is evaluated as fib of 5 plus fib of 4. Fib of 5, right? So we keep as it is fib of 5. Once fib of 5 is evaluated, the same can be substituted here. You could have said earlier, okay. This is fib of 5. Now this is fib of 5 plus fib of 4, the complete evaluation for fib of 6. Now to evaluate fib of 5, we need to evaluate fib of 4 plus fib of 3, then one more fib of plus fib of 5. Right, this is evaluated in the same way how we are evaluating this fib of 5. So we need to evaluate, right, fib of 4, fib of 3, then fib of 5. Fib of 5 is now we are evaluating as fib of 4 plus fib of 3. So I write in the next page so that evaluate fib of 4, from which right fib of 3 is evaluated. So look here, then we can directly substitute the values here to avoid more expressions. Fib of 4 is evaluated as fib of 3 plus fib of 2. This is one expression, this is another expression. These two are added to have fib of 4. Fib of 3 is evaluated as fib of 2 this plus fib of 1. Fib of 2, right? What is fib of 2? Fib of 2 is the value 1. Fib of 2 is 1. N is 2, result is 1. So put fib of 2 as the value 1. 1 plus fib of 1 and n is 1. The result is 0. So here this is 0. 1 plus 0, this is evaluated. 1 plus 0 is 1. And the result is returned to this place. So fib of 3 receives the value 1. Then fib of 2 is 1. Already we have the function called 1 plus 1, right? 1 plus 1 is 2. Fib of 4 is 2. So from this we have fib of 4 as 2, fib of 3 as 1. Substituting these values in the previous equation, we have fib of 4 as 2. Then fib of 3. What is fib of 3? Fib of 3 is 1 plus fib of 4. This is 2. This is 2 plus 1 plus 2. Am I correct? Fib of 4 plus 2. 1, 2, 3, 4. Yes, it's 2. Okay. Then fib of 3, fib of 3, 1, 2, 3. Fib of 3 is 1. Fib of 3 is 1. Then one more fib of 4. Fib of 4 is 2. Then fib of 5. 1, 2, 3, 4, 5. 5 is already fib of 5 is, have a look into here. Fib of 4 plus fib of 3, that results in fib of 5. So I put these two additions, 2 plus 1, 3, without evaluating further. So that 5 plus 3, 5 plus 3 is 8. Fib of 7, seventh number is 8. That we need to check. First number, second number, this is third number, fourth, fifth, sixth, seventh. Is it? Fib of n. N is equal to 7 means we have got the value 8. Fib of 7 is 8. So this is a way to check the correctness of this recursive relationship. So we have two termination conditions. N is equal to 1, please return a value 0. When n becomes 2, please return a value 1. Otherwise, when n is greater than or equal to 3, simply write a return expression, return fib of n minus 1 plus fib of n minus 2. Addition is carried out first, right? So evaluation, complete recursive calls are made, then final result is returned to the calling place. This is the logic of a Fibonacci number generation. Have any doubts? So we check its program. Please take the next one. New. Find the nth Fibonacci number using SIY, using recursion, and sketch its trace. Sketch its trace for n is equal to 7. Include the header file nth Fibonacci number recursion. Okay. Hash include stdio.fetch into main. What is the input required? Input required is the value of n, nth number in the sequence. Int n, like the factorial problem, is enter the value of n. Enter the value of n. Write a scanf statement, scanf percentage d ampersand n. Printf slash n percentage d. Alright. Fib of percentage d is percentage d, comma, first one is n. Second, assuming that we are defining a function fib, fib of n. The return value is directly processed in the printf statement. Finally, let us have return 0. Then write the function definition. File, save. Okay, function definition. Assuming the return type is integer 1, function name is fib1, actual parameter n is being passed into the formal parameter n. So in this fib of n, fib of n is a function call. This is a function call, I write it short, in which What is n? N acts as the actual parameter, actual argument. This is the function definition. This n is a formal parameter, and even this n is local to this function definition. That n is being copied into this n, that's all. Write the definition of recursive call of fib of n as we have verified fib of n. We have verified fib of 7 is 8. So write this termination condition first. If n is equal to 1, return 0. If n is equal to 1, what are we returning? Returning a value 0. So first termination condition is return. Second termination condition, when n is 2, return a value 1. If n is 2, or even we can write else part also, no problem. Return 1. If n is 2, is return a value 1. Then else, or you can use else conveniently. Else if n is equal to 2, return 1. Else, as we have solved for recursive sum problem, finding the factorial of the given integer. Here, to find the nth Fibonacci number, you can write a return statement with recursive call or with recursive calls. So, as usual, write the return statement by evaluating these two expressions. We need not worry about what is fib of n minus 1, what is fib of n minus 2. Of course, these two are the recursive calls which are called the same function repeatedly until the termination conditions. Either write n is equal to 1 or n is equal to 2 or both n is equal to 1 and n is equal to 2 or like that. So when n is greater than or equal to 3, that we make as in the else part, else, of course, in the else part, here the value of n, I write in comment else, the value of n is greater than or equal to 3. In this case, return nth integer is obtained by adding the previous two integers in that sequence, which are obtained as fib of n minus 1 as we have returned right in this diagrammatic representation. When n is pointing 34, n minus 1 is pointing 21, and n minus 2 is pointing 13. So write fib of n is equal to, this is fib of n minus 1 plus fib of n minus 2. Not n minus 2 plus n minus 1 is equal to n. But logically our problem is fib of n minus 2 plus fib of n minus 1 is equal to fib of n. So fib of n is, here we have returned fib of n is fib of n minus 1 plus fib of n minus 2. So this is being returned in the recursive call or the return statement. Fib n minus 1 plus fib n minus 2. No more statements are required. Closing the function definition. Okay. What is missing? Function prototype is missing. Have int semicolon. File save. F9. Let us check its correctness. Program has been compiled successfully. Control F9. Please enter the value of n. 7. Fib of 7 is 8. in case if we put right, this is 7, this is 8th number, 8, 9, 10, this is 11th number, 55, control F9, n is 11, yes, we have find the value 53. Have any doubts in this example? Another right, you need to do the trace as we did for the factorial problem. Here if you put take n is equal to 7, right? N is equal to 7 means already we have done the trace here. You can take the same trace. Fib of n is equal to 7. Fib of 7 is fib of 7 minus 1 plus fib of 7 minus 2, right? Write carefully the expression. So fib of 7 minus 1 6, fib of 7 minus 2, result is 5. Then 6 is obtained as fib of 5 plus fib of 4. Fib of 5, right, I have written as it is because I don't want to write fib of 5 again as fib of 4 plus fib of 3 because one fib of 5 is computed here. So I kept as it is fib of 5. Fib of 5, right, I have split into right fib of 4 plus fib of 3. The fib of 4 right kept as it is. So then fib of 5 right kept as it is. Then fib of 4, so we need to write expand the equation to avoid that, right, where we are computed fib of 4 separately, that's all. Fib of 4 is computed as fib of 3 plus fib of 2. Fib of 3 is computed as fib of 2 plus fib of 1. 2 and 1 are termination conditions. 1 plus 0 is equal to 1. So fib of 3 is 1. Then fib of 2 is 1. 1 plus 1 is 2. Fib of 4 is 2. Then we need a fib of 3, right? Fib of 3, second expression. Fib of 4 plus fib of 3. I don't want to write fib of 3 here by expanding as fib of 1 plus fib of 2. So from this, right, please recall this is a fib of 3 value, 1 that we have computed. So I have directly written fib of 3 is 1. These are the computed values which are actually computed by calling the recursive calls. Right? There is no doubt in that. But here, right, we don't want to write extend the recursive calls. Since one time we have computed for fib of 4 as 2, fib of 3 is 1. So this is 4 is 2, fib of 3 is 1. So I have written this is 2 plus 1, 3. 2 plus 1, right, 3. This is the actual value of fib of 5. So we have further evaluated the value of fib of 5 as fib of 4 plus fib of 3. This is fib of 4 plus fib of 3. Fib of 4 is 2. Fib of 1 is, fib of 4 is 2. 3 is 1. 2 plus 1 is 3. This is fib of 5. We have evaluated one time. So that here fib of 4 is there. In this fib of 4, right, I don't want to evaluate further because here this fib of 4 is 3. 2 plus 1, 3. Sorry, fib of 4 is, right, what on 2. Fib of 4 is 2. That 2 is reused here. Then this is fib of 5. Fib of 5 we have evaluated as 3. So this 3 is used. So that, right, we got fib of 7 is 8. So this is the trace, right, that you can reproduce there in case if you want, if they ask you to do the trace for n is equal to 7. Hope you understand this example. Again, you need to check for termination conditions. Control F9. N is 1. Fib of 1 is 0. Yes, correct. Then control F9. Sorry. Control F9. N is 2. Fib of 2 is 1. Control F9. N is 3. 3 is 1 plus 0. 1 plus 0 is 1. So the logic looks fine. Have any doubts in this example? If you have any doubts, you can ask now. No doubts? Are you all clear? So please recall the structure of recursion. Recursion is nothing but calling a function within the same function itself. Two things are important. One is a termination condition. One or more termination conditions are required. Another one, the recursive relationship, a recurrence relationship. We can have one or more recursive calls to be made within the function definition. Specify clearly the actual parameter and define the termination conditions and our recursive calls carefully based on the formal parameter of the function definition. So one stage is to reach the stopping stage, that means the termination stage. So after some iterations or after some recursive calls, one stage there must be the termination part, the recursion, that is achieved with the proper help of defining the termination conditions. So you can go through this logic, sum of n numbers, factorial of n, Fibonacci numbers. Using this, we can solve the problems which are based on the recursive applications. So whatever you have solved earlier using iterative applications, that can be converted into this recursive applications. If you have any other doubts, you can ask now. Next, I post some of the exercises. I show it here. What you have to do, you need to solve the exercises, and you need to upload it in the Drive. I post the questions. Before that, I show the questions. I think I have already solved these exercises. Hope you have uploaded all these. 1, 2, 3, 4, 5, 6, 7, 8. I think up to 9th, you have solved these exercises, If not, I add 9th one. Then the 10th one, you need to check if the given integer is positive, negative, or 0. For that, you need to write a program. If possible, use a function, or without function, you can achieve it. Then 11th one, check if the given integer is divisible by another positive integer. We need to tell the result. For example, output 100 is divisible by 25. Given two integers 100 and 25. Or 75 is not divisible by 80. Perfectly, you need to check. Twelfth one, leap year checking. 13th one, program to print the relationship between two floating point numbers. So given two numbers x and y, finally you need to display the result in any of these three forms. X is equal to y or x less than y. Your output is simply x is equal to y or x less than y, or output is x greater than y. Then maximum and minimum of three numbers. Most of the problems that we have solved in the class, if else nested if statements. Then 15th one, based on the situation, you need to check if the given integer, based on that integer, you need to display the message. For example, you are eligible for voting, you are not eligible for voting. 16th one, given 5 inputs, for example, marks in 5 different subjects, you need to compute the result, You need to print the result, if it is pass or fail. 17th one, given two positive integers x and y, such that x is less than y, you need to check another integer z. For example, if z lies in between x and y. Suppose x is 10, y is 100. If the input z is 120, please give the message. Z does not lie in between x and y. Suppose if z is 70, please print the message. Z lies in between x and y. Then 18 to 1. Same thing, right? Student mark statement processing. Just extend the program based on the result and average mark. The result is pass and average is greater than or equal to 75. For example, the problem requires to print as first class. If the result is pass and average is greater than or equal to 75 and less than 75, the problem requires to print the message as second class. If the result is pass and average mark is greater than or equal to 50 and less than 65, then it requires to print the messages third class, else you need to print, right? There nothing, right? So no need to check further. 19th one, try to read the sides of a triangle, say x, y, z, and check if it form a right triangle. So in right triangle you can find, right, the longest side will be the hypotenuse. So check for hypotenuse square is equal to sum of the squares of, right, remaining two sides. So different logic you can write like this conditional test, or you can find the largest number that is equal to the sum of the squares of remaining two numbers. If it's so, then yes, right, else print no. 20th one, evaluate the following if else statement. Y is equal to 2x plus 100 when x is greater than 100. Else y is equal to x minus 100. This needs to be evaluated based on the value of x. 21st, given two positive integers m and n, we need to find the addition and multiplication of m and n, that is m plus n and mn should be computed, and you need to print the result. Compare, right? Compare and print the result. You can print, right? M plus n is greater than mn, or m plus n is equal to mn, or m plus n is less than mn. 23, given three integers a, b, c, find its arithmetic mean and geometric mean. Then compare the results. If arithmetic mean is greater than geometric mean, or if both are equal, or if the first one is less than the second one. 23rd, given four Cartesian coordinates x1, y1, 23rd, right? Okay, x1, y1, x2, y2, x3, y3, x4, y4. You need to check if the points are forming a square or not. Square, right, as a two-dimensional figure. So the points are taken in the order A, B, C, D. So check if A, B, C, D are forming a square. So find the Euclidean distance. AB square, right? This is AB square. Then find the Euclidean distance BC square, Euclidean distance CD square, and Euclidean distance DA square. So finding that, we can conclude if the given points, right, are forming square or not. So I post right up to these problems, starting from I think 9. If it has already been solved, okay. Otherwise, you need to include 9 now. So these highlighted problems should be solved. So please upload the answers as you have already done. Create a separate folder if not already done. Upload the folder. You try to write, upload the answers, right, in that folder. To solve the problems in your site, you can use the online compiler or you can use any compiler. Save the file, for example, exercise 1, exercise 2, or have a reasonable name. minimum, maximum, something. Then upload the files, right? In that folder, I will check, right, your uploads. Have any other doubts? You can take your time, right, to upload the answers. I have not given any deadline, so please take, right, at least 1 week. So try to complete it within, right, 7 to 10 days.
Okay, sir.
Have any other doubts? Okay, practice these exercises well. If you find any problems in this, right, feel free to ask me, right? I clear your doubts. Prepare well. We discuss in the next session. Thank you very much.
Thank you, sir.
Thank you, sir.